on physical machine. Then we realize we are not going to utilize the 100% of the resource of that physical machine. Then industry is going to introduce virtualization. Virtualization. Virtualization already you completed on VMware. We are going to install Linux machine, that is virtualization. But still we are going to face that my virtual machine operating system is going to use huge resource. When we are going to install CentOS or Rocky or Red Hat, that software volume is more or less 5-6 GB to 10 GB around. This Linux 9, this ISO file size around 10 GB. And when I install it in virtual machine, it is going to use more resource, minimum 1 GB RAM, hard disk space, some process cycles. So industry again they try to think it that this guest OS, the virtualization, that guest OS, it should be use minimum resource. It should be lightweight. Okay, it should be lightweight. So again industry is going to introduce Docker container. Okay, Docker container. So what is this Docker, or which is known as container engine? So first try to understand the virtualization. So this is infrastructure. Check it, my left hand side. This is infrastructure. That is my hardware. On that hardware, industry is going to use one virtualization software which is known as VMware ESX. It is not like VMware Workstation, VMware ESX. Okay, it is known as hypervisor. In AWS also you are going to face virtualization or hypervisor Zen and Nitro. On this hypervisor, now we are going to install GuestOS, CentOS, another Linux, Red Hat, Windows, as per our requirement. On that we are going to use, because OS is going to use some library files, some binary files. Then on that we are going to install applications, database and others. But when I check it, my GuestOS is going to use huge resource. So how to lightweight this, how to minimize it? Now comes to the container engine. Infrastructure, then operating system, and it should be Linux. Then on Linux we are going to install container engine. Container engine type, so many softwares are there. Famous one is Docker. Linux also introduced one, Podman, and other few other software. So container engine means we have to install the software, that is Docker. So operating system Linux, container engine, that is Docker, and then here it is GuestOS means complete OS. Here GuestOS only binaries and libraries which is not related to this base operating system. Because Linux is running here, only few options is here. Rest portion it is going to accept from the base operating system. So this GuestOS, CentOS, say it is 10 GB. Here it is, when I am going to install CentOS on Docker container, this CentOS, here it is ISO file. On container engine on Docker, it is known as not ISO file, it is known as image. This ISO file size around 10 GB, this image size around 100 to 200 MB. On that application is going to run. But Docker container, one disadvantage is there. Suddenly container is going to down. So if container is going to down, application also down. So once container down, automatically container should be going to up, and scaling options. These are all maintained by Docker Swarm, SWARM, Docker Swarm. But industry didn't accept it. Industry accept Kubernetes. So basically Kubernetes is going to manage this container. So Kubernetes is known as container management tool. Multiple container, that is high availability. Okay. Auto scaling, automatically scale up, scale down, and auto healing. If any container is going to down, alternately before down that container, Kubernetes is going to start another container with the same applications. So first we have to know Docker up to a certain level, then projects, CI/CD, then advanced, then Kubernetes. So let's see how to install this Docker software. On that Docker software, how to deploy any application. Okay.
Sir,
Hmm.
what is the difference between image and the real OS? I understand that I don't understand like what exactly is the image.
It is
When you
internal.
mount it, right?
Internal. Suppose if you want to install any operating system, then you have to use your pen drive or CD-ROM, CD drive. Okay,
Okay.
you have to bootable it. Then only it is possible, right?
Mm-hmm.
So these are different format. OS level, different architecture format. Here it is ISO file. Okay, and here it is image. That means Docker container can understand it. So the team who are going to develop this Docker software, Docker engine, so Docker engine understandable that image. So that is a different format. Suppose if I place you one something written in English or Hindi or Bengali, you can read it. But in Tamil or Malayalam, you cannot read it. So it is according you. You can read it. So Docker, when it is developed by the team, this Docker, so Docker engine can read it. Accordingly, they are going to develop the image. Within this image, what happened? That is what actually is there inside of image. See, in gates to OS, every total A to Z of the OS, but inside of image, it is only important part of the OS and the mandatory part of the OS and the part which is mandatory to communicate the actual operating system. See, total operating system is here, but within this binary library, just simple one part, 1% of the operating system is there. Now, if anything is required, it is going to contact to main operating system. So, this Docker, the team who are going to develop it, they are going to think why operating system is number of times. Here it is operating system number of times. Suppose this is also sent to us, this is also sent to us, this is also sent to us on that different application. Here it is only one operating system fully, and these are just CentOS or Red Hat or any other. They are particular some file, that important file, which file is going to communicate with operating system and continue the job. So that is the image concept. One architecture, one particular file which is possible to understand by the Docker engine.
Okay, just asking, like, let's say, like, the way we do virtualization, I mean, we divide one particular big PC, big PC in the sense, like, with more storage, let's say 1 TB, 2 TB, or 5 TB, and with a big RAM, we divide that according, like, 1 TB to 10, one GBs, like, different VMs, right?
Hmm.
So in that one, each VM, we can put our own Docker containers. Is it possible? Because that would be more effective, right? Like, I'm just thinking that. I mean,
Your requirement is physical machine, then you are installing virtualization VM on that VM Docker.
yeah.
You can install it. But
Acha.
but why we are going to use again VMware? Because this OS is going to use more resource, unnecessary. If
Okay.
your machine,
Okay.
suppose your infrastructure is 16 GB RAM,
Mm-hmm.
okay, 4 processor. So your Docker container is going to use it, and multiple container you can create here. Okay,
Okay.
it is not that you are going to create virtual machine on virtual machine. We are going to practice on virtual machine.
Mm-hmm.
Just think about this. This is not a virtual machine. This is a physical machine. So on that physical machine, we are going to learn it. But in industry, these are all physical machine. Say Netflix, they are using 5,000 machines nowadays. 5,000 physical machine around. On that, Linux is running. Okay, on Linux, Kubernetes is running. And Kubernetes is going to use container. Whenever anybody is going to log in, anybody is going to choose the picture, I want to see this movie, then some operations are there, and this movie and others application is running on container. Once user is logged out, container is down. When movie is running, by that time also, in between, suddenly container is down, Kubernetes is going to automatically run another container. End user cannot understand what happened. Okay,
Okay.
so container, this Docker we are going to install on physical machine. This is on operating system Linux. On that operating system, now as per your requirement, you can create multiple container. You can mention this container is going to use how much memory, how much CPU utility, how much disk space, everything. But initially we are just try to understand what is Docker, what is container, how it is. So let's see. So Docker installation, first options, then we will check the Docker versions, and then we will create one container. Container means just think about it's a lightweight one virtual machine. How to start this machine, how to stop this machine, how to move inside of this machine, outside of this machine, that is the container. And then how to deploy anything. So installation purpose, yum install, yum util, this is a mandatory requirements, prerequisites. Then what is this? Docker CE repo, community edition, Docker CE repo, that is repository of Docker. Then we are going to install Docker community edition with the help of the repo. Now once Docker installation over, you can check the version.
Sir, this is also open source.
Ah, Devops totally open source.
Mm.
One or two tools is not open source. Say 28.0.4. Now start the Docker. enable and check the status. So Docker is running. Now Docker info, it is going to show you information of Docker in details. If you check Docker info, it is going to show detail information, version and others. This is Docker info command, and it is going to show number of options. Okay, right now you cannot understand, but slowly you are going to understand what is what. Okay, so Docker installation over. Now what is our target? See, whenever we are going to create any container, install any container, from where it is going to install the container? Because container creation purpose, what is the requirement? Image. Now in my local machine there was no image right now. Image is available in Docker Hub. Docker Hub just like GitHub. Okay, Docker Hub just like a GitHub, one registry is there. So Docker images, using this, what I am going to check? Show any images there in local machine. So if I want to check Docker images, it will show that there was no image right now. If I want to search any image, say Ubuntu image, on Hub, Docker Hub, that is central repository, with the help of internet, you can utilize Docker search, then your image name. So it is going to search in Docker Hub, that is the central repository, and it will show the output which is possible. Error response from daemon, get https index docker search tls sec timeout. Internet problem. Some timeout options are there. Okay, if I want to pull anything, let's see. Then
Sir, this image is only for operating system, like you are searching for Ubuntu or
yeah,
anything.
Ubuntu, that is Ubuntu image, same as Ubuntu operating system, but it is only for container purpose. You cannot install any virtual machine or any physical machine from here. IP is there. Actually, in this machine yesterday I installed some mail server also. Maybe that is one more problem. New TF Rocky 9 Docker. So this is one ready machine, that is Docker is there. Docker hyphen version. This version is there. Now Docker images. These are the image already available in my local machine. My Pi image, Ubuntu, CentOS 7, CentOS latest. 4 images are there. If you want to check in Docker Hub, then this is the command. it is going to show number of Ubuntu images available in Docker Hub, that is in central locations. Okay, different version, different options. Now if I want to pull anything, I can pull it. Now what is my target? I want to create one container. But before create container, you just check dock here docker ps. It is going to show there was no container, running container. Any container, maybe it is in stop status. Yes, container is there. One container name is this happy pick, and another one is SDLC7. It is from Ubuntu image and it is from CentOS 7 image, but these are all exited, that is stopped. These are exited, that is stopped. It is not running. 3 weeks ago it is created. Now I am going to create one new container. So what should be the command? Command is docker, then run -it. IT means interactive, I for interactive mode, and T for terminal, that is automatically it will move to terminal of the container. Then -name, container name. Suppose I use container name SDLC. Then we have to mention the image, say CentOS or CentOS. If you mention only CentOS, it is going to use latest CentOS version, CentOS 9. If your target is not CentOS 9, CentOS 8, then you can mention CentOS:8. Then it is going to install CentOS 8. Then bin bash, minimum requirement if terminal is there. So let's see. Now two container is there, but both are exited, that is stopped. So docker run -it -name, my container name. Suppose my test, this is my container name. And then which image I am going to use. Small image also you can use. Alpine, that is also one Linux, and bin bash. It is searching this image Alpine is available? No. So it is pulling. And after pull, it is going to show download newer image, error response from daemon, failed to create tasks for container, failed to create this. Systemctl restart docker. If there any problem, I am using CentOS then, or Ubuntu lightweight. No, some issues are there. My test already there, so we have to use SDLC1. So it is created SDLC1 and I am inside of this container. Check it, it is changed. When I started, I am in PC doc, that is the host name. Now I am inside of this Docker container. Okay, you can check ls, I'm inside of this container. It is showing all the informations. Now you may use exit. If you use exit, your container is going to close, that is stop, down, and exit from container to host machine. Or control PQ. Control PQ means I exited from the container to my host machine PC dock, but still my container should be up and run. Let's check it. Docker ps is going to show you only the running container which is up about a minute, and name of the container is sdlc1 using the image ubuntu, and this is the container id bin bash, and it is up. Okay, if I want to move inside of this container again, it is running container, so we are going to use docker attach sdlc1. Before that, I'm just going to check docker ps minus a for all, that is which is up running. See, Alpine through also 2 minutes ago it is created, but it will show some error because daemon is not running that time. And Ubuntu related it is up about a minute ago SDLC1. Even if I didn't mention any container name, automatically Docker engine is going to use one container name. Okay, so now this container, first one, SDLC1, it is running. So let's move inside of the container. Then what to use? Docker attach SDLC1. I am inside of this container. How to check? Check it. 4FC7. The ID 4FC7. The same. I am inside of this container. If I use exit and try to check all container options, it is going to show exited. Now it is not up and run. It is exited. Just 4 seconds below. Before 4 seconds, it is just exited. Now my target is I want to start that container. So docker start your container name. Docker start your container name. Check it again. Docker ps. Now it is up. So you can start, you can stop any container, and when it is started, when it is running, you can move inside of the container. You can remove or delete any container using docker rm container name, but before that it should be in stop status. Okay, any doubts up to this?
Sir, Docker attach SDLC and Docker exe it SDLC both are same, right?
Number of commands are there, but execute later we are going to discuss when we are going to use see docker run, docker execute, different differences are there. So we will discuss that time, but it is more or less same type.
Okay, sir.
You can pull any, pull means download, docker pull any image name. If I create one container, docker run hyphen it, I didn't mention any name. Okay, and I am using CentOS latest bin bash. Check it, automatically it is going to use one name. So control PQ and let's check docker ps only running. So this is 11 seconds ago using CentOS. Okay, and when I inside of the container check it, 69A8. This is 69A8. What is the name of the container? Objective something. Automatically it is going to use one name if you didn't mention the name. Next option is, see, this is CentOS, Ubuntu, these are available in market. That is in Docker Hub. But your company, they want to utilize their application on container. Python application, Java application, any application. They want to deploy on container. Now how it is possible? It is possible through Docker file. We have to create a Docker file. Docker file name should be Docker file and D capital. Normally it is in current location, but in future we can utilize in different location also. I will show you that. And then add instruction in Docker file. So we have to learn little bit of this Docker file, the code. Then we are going to build the Docker file to create the image. Right now we are using image to create the container. So we are creating container from image, and image is available where? In Docker Hub, that is central repository. Now our target, we are going to write Docker file as per our requirement. Within this we have to mention our base OS. Then we have to mention our application, maybe in Python, maybe in Java, maybe in Node.js, anything. All the instruction is over. Then we are going to create image from this Docker file, and that is known as build the image from Docker file. Okay, and run image. Then we are going to create one container with the help of this latest image which I create. Just now I created. So just some sample, try to understand that Docker file, how to create the image. Tomorrow we are try to create using Python application inside of Docker file, Python application, and Python application to image, image to container, then access the container. Okay, today you just try to clear Docker concept, installation, and then creation of container, moving inside, outside, start container, stop container, and then this Docker file concept. So let's create one Docker file in this current location, or you can create one folder, and inside of that directory you can create Docker file. And I am using just simple one commands. Okay, so let's see. Mkdir my my Docker file, and cd my Docker file. Now we are going to create vi Docker file, D capital, press I. So here we have to mention from which OS. Okay, from which OS. I am using CentOS, Ubuntu, no issue. Now next line. This from maintainer, run, expose, cmd, these are all capital letter. These are all reserved word for Docker file. Okay. Now I just use one CentOS, and I am going to use just one line. One minute. हाँ बोलिए. हाँ क्लास हो रहा है. पता नहीं मेरा नी में थोड़ा पेन है. सीढ़ी सीढ़ी चढ़ने में दिक्कत होगा, इसलिए मैंने घर से ले रहा हूँ. क्या लिखना है? मैं क्लास के बाद बात करता हूँ, उससे बोलिए 10 बजे फ़ोन करने के लिए. नहीं, वो रूम पे नहीं होगा, वो ग्लास वाला रूम पे नहीं होता है. Okay, so I'm echoing test, just one line. This one to tmp out out, one file. What is the meaning? It is going to pull CentOS, and then it is going to execute this command test dot 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 inside of out file under temp. Okay, nothing else, only these two lines. So from this Docker file, if I create my image, and then if I create one container from that image, inside of container this out file should be there, and the content of this out file should be test dot dot dot. Then it is going to prove that Docker file to image is created, and from that image to container is created. Okay, tomorrow we are going to use real-time Docker file using Python project, and we try to create the image. Then we have to know how to push this image to Docker Hub, and try to create container with the help of that new image, that is our custom image from Docker Hub. But today try to understand this Docker file to image, image to container. So Docker file is ready. Now this is the command docker build -t, t for tag, and this is your image name. You can use any image name, and dot, that is Docker file available in current location. Okay, so docker build -t, name of the image, you can use any name. Here I use my img. Before build this, just check docker docker images, my py image alpine ubuntu centos. Okay, so this image is not available. Docker build -t my img 99 and dot. Okay, enter. Again execute docker images. Check it, my img 99 image is created, 231 MB. Fine. Now I want to create one new container with the help of this image, pushing tomorrow after creation of proper image using Python code. Now I want to create one container, and I want to check that particular file out under temp. So docker run it name my container 99 and image my image 99 bin bash. Container created, and I'm inside of the container. Okay, now what to do? We have to check ls-l/tmp. Inside of tmp out file is there, and what is the content? cat/tmp out. Check it, test dot dot dot. That means it is proved the image which I use here, my img99, this image is created from that Docker file. So Docker file to image, image to container, and this is my customized image. Just testing purpose, understanding purpose. But tomorrow we try to use one Python code how to convert it as a image with the help of Docker file. Then we create container. Then we access our container also. Okay. So today what is your target? Your target is Docker concept, how it is different from virtual machine, and Docker software installation, then how to check the images in local machine, images in central hub, how to check the containers, running container or all container, how to create one container, how to stop and start container, how to move inside of the container, how to move outside of the container. Exit and control PQ, two options. Exit means container should be stopped, and PQ, control PQ means container should be up and run. And then Docker file, very simple one Docker file, just learning purpose. So Docker file to build image, image to container. Tomorrow real-time Python project or Java project, Node.js project I will share. You just try it, and then we create image and create container. That is one side. Another side is access the container also and push the image to Docker Hub repository, same as GitHub repository. Okay, Docker Hub is going to store only the images. So in your repository you can store your own image. That is our tomorrow target. Okay, so please try to complete it. Any doubts?